Hi, I'm Zainab Adjiet, and this is our demo for the honors project CADaFloP, or CARTA-DataFlow prototyping. It was supervised by Rob Simmons, with co-supervisors Adriana Pinska and Kirchel Kirkham, and my project partner was Dylan Fouché. CARTA is a tool for visualizing astronomical data. It's made up of a front-end web-based client which receives processed information from a back-end server. With HPC approaching the exascale era, CARTA needs to explore new architectural models to find a sustainable way forward for the system. This project explores using the Python Dask DataFlow environment for the CARTA backend system. Dylan explored this from an implementation standpoint, and I explored this from a systems engineering standpoint. Dylan will first demonstrate his part of the project.
We're looking now at the front end, which runs in the client browser. The back end is a multi-threaded C++ server, and in this project, we investigate a new implementation of the C++ back end using the DataFlow architecture in Python, and we aim to evaluate its performance and scalability versus the current implementation. In order to evaluate our hypothesis, we implement a set of backend components using the Python Dask library for DataFlow computing. This involves defining an image class which will read in some astronomical image and persist it to distributed memory with Dask. This also serves as an entry point to performing various computations over this image data with Dask. We have several options for how we want Dask to execute this computation, ranging from executing on a single machine to executing across a large distributed cluster of machines. To use our image class, we define a Python server that behaves identically to the CARTA server under a certain set of computations. We also define a Python client which can connect either to our backend server or the CARTA backend server for reasons of testing and validation. To prove that the prototype components behave correctly, we compare their output with the output from the CARTA backend. We also subject the prototype components to performance testing for a range of different backend functions and under various execution conditions. These are the results of those performance tests. We find that in the best case, Dask can significantly outperform the CARTA implementation, and in the worst case, they perform about the same. Since Dask is also significantly more scalable than the CARTA implementation, we find that a DataFlow model would be a feasible way forward for the CARTA backend.
This project explores a DataFlow redesign of the CARTA backend system. This is an overview of the diagrams I constructed throughout the project. I won't be covering all in this video, but all diagrams can be found in my project technical documentation. Shifting the CARTA backend system to a DataFlow model offers the benefit of code simplicity. The structure of the proposed system is logical and can be easily extended to include the full functionality of the current backend. The Python language itself leads to simpler code that is easier to understand and follow than the current C++ code, which may make the code base easier to modify and extend if need be. The Dask scheduler allows the execution of CARTA operations to be generalized so that the server need only pass the necessary function and data to the scheduler to execute the required operation as seen in the second level general DataFlow diagram. This generalization will aid the modularity of the backend server and allows for easy expansion of the operation list with minimal code additions. This diagram also abstracts from machine specifications of the individual cluster nodes, as Dask need only be supplied the cluster of machines to execute the operation over. This does not restrict the Dask cluster machines to any one type of machine specification, and the backend operations can potentially be executed over heterogeneous clusters. So while the design itself offers no drawbacks, the shift to Python from C++ may result in a notable performance decrease for some or all CARTA operations, as the CARTA system is already optimized to perform these tasks. Nonetheless, the shift to the Dask DataFlow environment for the CARTA backend is a worthwhile venture. It can provide many long-term benefits for the CARTA system going forward, and Dylan Fouché's prototype lays reasonable grounds from which to start. Thank you very much.